So the remainder of question 9 is separated out from the 6 marker, just so you can focus on those separately if you want to. So they're in their own playlist. But taking a look at this question, we are moving into calculations once again. First step on this is always to draw out the table. And the table has initial moles and equilibrium moles. And what I'm then going to do is start to fill those in based on the information that's being provided within the question. So you can see here the 20.1 and the 24.2 that are ready to go in directly. That's where I'm going to stop for now, and I'm going to go on now to deduce something. And that is that I've got 0 moles of the product, which at the beginning makes absolute sense. Now, once I do that, I can put my equilibrium moles of methanol in, my 2.16, and I've now got everything that I need, these numbers, in conjunction with the equation to work out the remainder. So I'm going to work out my equilibrium moles of carbon monoxide. 1 mole of carbon monoxide makes 1 mole of methanol. We have a 1-to-1 ratio within the equation. So if 1 mole makes 1 moles, 2.16 moles makes 2.16 moles, and therefore we subtract 2.16 from 20.1, and that's where that number comes from. Slightly more complicated here, we have got 2 moles of hydrogen make 1 mole of methanol. So if I've made 2.16 moles of methanol, I need double that of the hydrogen. So that's how much it goes down by. And I've now got my 2 figures to go in at the bottom of the page. Moving on to another calculation here, and we're actually on to KP now. So this is the year 13 topic that you moved on to. And we've got a mark for the expression. Now remember, with KP, we don't use square brackets. We do need to recognise that they're pressures, and that's what the P's here signify. Products always go over reactants, and we've got that from the equation on the previous page, and the powers on here come from the balancing of the equation. Now at that point, once again, I need to start doing some calculations. If I am going to know what my mole fractions are, I first of all need to know what the total moles of gases are. So I've taken the 3 figures that I've colour coordinated here, and that means I've got 7.63 moles of gas. Now to work out the mole fraction of each of the gases, I'm going to find out what their mole amount is as a proportion of the 7.63. So that's my mole fraction, but I also know the total pressure. So that they are going to have that fraction of the total pressure, which takes us through 2 ticks, 2 marks for working out the 3 correct partial pressures. And if you ever want to do a very quick double check that you're on the right lines, if you add up all of those pressures, they should add up to the total pressure. As you move on through, you then get the calculation done and you get the figure that you've got there. That's simply substituting those numbers in. And then for the units, I've tried to break down how we are going to do this. If you simply substitute the units in rather than the figures and then cancel out what's left, you're left with 1 over kilopascal squared, which in standard form is kilopascal to the -2.